Alright everybody, let's see if I can do this in one shot. I'm going to be building a heat treating oven and also a glass blowing annealer out of this large rural mailbox. Amazon review, somebody put their kid inside here. It's pretty big. It's 23.5 by 14.5 by 11. It's going to get 2 inches of insulation all the way around. It's going to have a hard floor, kiln shelf floor, and just wanted to go through some of the calculations I'm going to be using, or what I came, how I came to get what I've got. I'm going to be using 18 gauge Canthal A1 wire. I'm going to do another video on how to explain how to get your calculations and do your calculations and figure out how much wire you want for any given volume. So you want a big kiln, big annealing oven, a slumper, a fuser, something like that. I'll do that later. I just wanted to go through this and show you guys what I'm doing here. So I've got 23 inches. The mailbox is about 23 inches wide, and that's kind of how much wall I have to work with. So for this space I want, I'm going to do 12 amps at 120 volts, and I'm going to do that with 2 elements. So what I'm going to do is I'm going to divide that by half. So I'm going to have 2 sets of elements running 6 amps at 120 volts. So we've got some stuff here for A1 wire. We have a diameter, and that is 0.0403. We're going to knock off that 0.03. That's 1/1000th of an inch. This is drawn wire. I don't think they have quite that tolerance on the wire, and it's just not going to matter to us. It's not going to have any tolerance stacking or anything like that. So we're just going to go with 0.04 as the diameter. The resistance equals 0.5387 ohms per foot. We have a surface area as well. This is going to be important. That is 1.5194 square inches per foot. So now we're just got to figure out how much wire we need. So we've got 6 amps. Let's see. I'm going to do a little diagram here, a little Ohm's law diagram. This is very helpful. And if you need to find volts, amps, or resistance, you can just cover up one of these and you'll get your operations. So this is the same as volts, amps, resistance. So what we need to do to find resistance is we're going to go voltage over amps. So that's going to be 120 over 6, and that is going to equal 20 ohms. So now that we have our resistance, how much wire is that going to equal? So we got our wire here is 0.5387 ohms per foot, and we need 20 ohms. So if we do that, if we do 20 divided by 0.5387, we get about 37 feet, and that's good enough for us. We're going to be winding this on a 1/4 inch mandrel, so our mandrel is equal to 0.25. And what I'm going to do is go through and show you how to calculate your close wound wire length. So after this 37 feet of wire has been wound on this 1/4 inch mandrel, how much wire are we going to have that's wound before it's stretched. And that's helpful when you're building a kiln if you want to figure out, how many wires can I put in here? Will it fit? And that kind of thing. So let me just get rid of some of this. Let's see, 37 feet, we said, of wire. We'll do away with that there. So when we're winding the wire, we've got our 1/4 inch mandrel, and then we're going to have our wire that's wound around it. And so what we're concerned about is measuring from the center of the wire, so it'd be helpful to know the radius of the wire and then add that to the 0.25. We've just got, we've got 2 radiuses which equal the diameter, so we're just going to add 1 diameter to our mandrel, and that's going to give us the diameter, total diameter of wire diameter of 0.29 inches. So we will find, what we need to do next is find the circumference of that wire as it goes all the way around. So we're going to take that 0.29 and multiply it by pi. There we go, that's pi. And what we end up with is a 0.911 inch circumference. Hope you guys can read that. So 37 feet, we'll take 37 feet, which equals 444 inches. Did I say 444? Yeah, okay, 444 inches. And we're going to divide that by, let's see, 444 divided by, what did I say here? 0.911, that's right, inches. And what we get is 487 loops. 87 loops. So now, what does that mean to us? So we've got 487 loops. Loops. That's how many times it's going around. And each loop is going to be, what did I say, 0.40. Each loop is 0.04 thousandths of an inch, 40 thousandths of an inch, sorry. And what we do to find out how long that's going to be, we're going to multiply the 0.04 times 487. Make sure I've got this right. Sorry everyone, 487 loops times 0.04. Alright, and that will give us 19.48 inches close wound on the mandrel. Okay, that's great. So when I'm looking at my box here, that's there's going to be insulation on each end, so we're going to end up at about almost 20 inches, 19.5 inches. That'll fit right here. But what I need to do is I need to stretch that to about twice its length here. And that is going to give me, I'll have something like that. And I'll have room. So that's good. These elements are going to be inside of a quartz tube. It's a almost pure silica tube and suspended from the walls. You may see this, they do this with toaster ovens, that kind of thing. You'll sometimes see the elements suspended in there, and it's a great way to protect the elements, and it's an easy way to hang things. The quartz, it melts at incredibly high temperatures. It's stable, and it's kind of the perfect thing to use for this situation. So we've got that information. That's good. Now we want to talk about something else, and that's wire temperature. And something we need to also pay attention to is the watt loading, or how many watts per square inch of surface area we have. And we'll get a number for that. So surface area right here, we're going to call that 1.52. Okay. So let's see, we have 37 feet of wire. And we have a surface area of 1.52 square inches per foot. So let's multiply that, 1.52 inches per square foot, and what we end up with is 56.24 square inches of wire surface area. So now we'll take, this is going to be, this element right here is a 720 watt element. We're going to have two of them, if you remember. And so what I'm going to do is I'll take my 720 watts and I'm going to divide that by 56.24, and that is going to equal 12.8 watts. Sorry. 12.8 watts per square inch of element surface area. This is a good number for A1 wire. We're going to be going up to about, heat treating oven, probably, 1700, maybe a little more. And if you're down in this range, down below 20, down below 15, for higher temperature applications, that's a great number. So the hotter the wire temperature, the hotter the element gets, the more it's going to oxidize and the faster it's going to oxidize. And this number, this watt loading, is going to keep the element relatively cool. You can put a short little wire in there of a different gauge and get your number, but if you have 100 watts per square inch of surface area, that element's just going to go up like that. So, quick little video. This is a free one. I'm not really going to go. I'm going to build this, and it'll be a build log from the Patreon channel. I'm not going to really go through this, but I thought it'd be a good free one to put up there and just show people what's going on, what's behind it all. And I hope I got it. I hope I got it all in one take. Thanks, guys.